Thank you, Gopi. Yeah, I'm Justina. So yeah, I work at Huawei Canada, and I guess you guys already familiar with me. Yeah, this morning the Henan session. So in the next 60 minutes, I'm going to talk about evaluation of your AIware. This doesn't work. Okay. It's on. It doesn't work. It doesn't work. Okay.
You can use it over here.
Okay. So yeah, technical issue a little bit. So this is the overview of the session I'm going to talk about. So the first is kind of the image that you guys get familiar with what AIware looks like. So AIware, as you know, it's a system, contains a lot of different kind of components, including foundational models, components, retriever, whatever you can think in the traditional software, and the new things in the AIware. And then it becomes a compound system that the Berkeley researchers already use this term. So this is just an image that the things you're going to know, and you're going to do evaluation on this kind of complex system. So this is just kind of the image that you guys to have kind of impression of AI system. So AIware, if there is a problem, then this is a two example, Air Canada, their chatbot told a customer that it gonna get reimbursement after he attend his grandmother's funeral, and the reimbursement was about $880. But Air Canada declined that discount because the chatbot had a hallucination, and that is a standard example when you have a poor quality of AIware. It's gonna ruin your reputation. That's the first one. Another example is Google Gemini. You probably read the news about Google Gemini generate this offend pictures for soldiers in colors. And that is another thing about you have a poor quality AIware. So that's why you need evaluation. And there are also surveys from expert AIs from the industry people saying this is kind of the concerns they have for their AIware, the hallucination, the example I gave. And also the second one is the BIOS, also the example I gave from the Google Gemini. And the third is leaks of the proprietary data, which is privacy issue is very important, and so on. So far, there are a lot of concerns for the quality of the AIware. And Andrew also mentioned evaluation is actually the key that would impact the fast moving of your Gen AI application, which is the AIware. Because the AIware, it contains the foundational model, which would increase the creativity of your application, but it's gonna be a new era and new challenge for you to evaluate your AIware. So having a good evaluation is quite difficult. Andrew Capacity mentioned, good evals are very difficult, and when he was at Tesla, he spent 1/3 of time on data, 1/3 of time on evals, and also 1/3 of time on everything else. And if you want to have a good eval, it's very difficult, and it's kind of work intensive, but it's quite important for your AIware. The reason I gave before, your reputation, your quality, or you're gonna give unfaithful data for a user. But if you want to do evaluation, it's gonna be difficult because you're gonna have a lot of moving parts in your AIware system. This kind of the image about a typical AIware system related to RAG. So you're gonna have a lot of stuff inside there. I'm not going to go detail. It's just kind of the image that give you guys the flavor of how you're gonna evaluate a typical system like RAG, because RAG is so commonly used in AIware. And that's the motivation why you need eval. And next one, I'm going to talk about how do you design and create evaluations. So when you are doing evaluations, first you need to know what's your subject. So for AIware, actually it contains like a foundational model and also another components. And I'm just saying like the other components were more like the traditional software application or software apps. So which means you could determine the output of these kind of components or like tools. So it's more like back to the traditional. But for the model, which is kind of like a new instance in AIware and also a new instance in the current software engineering area. So you need to know you are going to evaluate the model or you're going to evaluate end-to-end of your entire AIware, which means they include the interaction between the foundational model and components, or you're gonna have a chain like RAG, you're gonna have upstream knowledge and then downstream foundational model or downstream task, or maybe like agent. So you need to know what's your subject you want to evaluate. And I'm going to talk about a little bit terminologies here because this kind of terminologies, some of them are interchangeable in certain scenario. So evaluation, or maybe sometimes you will hear like just say eval. So it's more about you want to know the overall performance of your model or AIware, whether it's reliable, it's aligned with your goals, or and the quality, safety, or BIOS, those kind of stuff that you wanted to make sure it's good. So sometimes evaluation is also mixed used, interchangeable is like testing, benchmarking, and guardrails. But evaluation is more about the general thing and including all of this detailed stuff. And I'll talking about these other terms later. So next would be testing. So testing is more specific to you want to examine a specific functions or behavior, whether it's a FN or it's an FN with a software component or whatever context you have. So you want to specify your specific scenario, like for example, the use case you want to test whether the FNware would use the knowledge you gave, or the knowledge you gave is correctly for the FN to answer your question. This is kind of, you would define the scenario you wanted to test, and then you do the testing. So testing is just part of the evaluation, and sometimes testing is interchangeable with guardrail if you are talking about like security or safety topics. And benchmarking is another term that you will hear when you are doing evaluation. So benchmarking in a general concept means you want to compare the performance of the foundational model or your AIware against your predefined benchmarks. So you want a general standardized result so that you could evaluate your the performance of the quality of your model and the performance of your AIware. So sometimes benchmark, you need to generate the data and have a data set. So sometimes benchmarks are interchangeable with data set in the context of evaluation. And then data set, yeah. Data set is like in general is any kind of data you could use to train or fine tune or evaluate your foundational model or do whatever you want. This is a general concept of data set. But while in evaluation, data set and benchmark is just, I mentioned before, it's more like interchangeable in the context of eval. And guardrail is more like for security or for constrain what's the behavior your model or your FNware will do. So for example, like the Air Canada case I just gave a discount of $880. It's quite large for flight tickets. So maybe you could set a simple rule-based rule for your AIware, just saying like it's impossible to give a discount of over like $500. It's a lot for flight tickets. It's just an example in case like you wanted to constrain the output of the AIware, because there is a foundational model inside your AIware. It produces the creativity of your AIware, but it's gonna be an unlimited set of the response that you could not specify in your test case. So just quick summary. So evaluation including like testing, benchmark, and guardrails. And testing is more about just guardrail interchangeable in the case, and benchmarking usually is related to is referred to you wanted to evaluate the performance. But benchmarks is interchangeable with data sets, and guardrails sometimes is interchangeable with testing. So evaluation, I think I talked a bit about why we need evaluation. So you wanted to identify the errors, and you wanted to make sure the performance, and you want to debug your issues in your specific context or general context, and then because AIware is still a type of software, so you're gonna have new changes, new features, new updates, and also there are like new models coming out every day, and then you're going to use more powerful model. And if you do any change, you want to make sure your system is still adapt to the old scenario and also new requirement changes that you have. So you need to certify these goals and then make sure users trust. So there's a typical evaluation process that you may already familiar with, because this is just simply the traditional software testing process. You need planning, you need design, and then you need design, and you need execution, and then you have the results, and then you interpret the results. So I also list like the detailed stuffs here about what kinds of things you would do. Like when planning, you need to know the goal, like you wanted to evaluate the quality and the requirement, like accuracy of 90 or something, and then you define your evaluation criteria. And after that, you would design task, data sets, and test strategy, whatever. I'll talk about that a little bit later. It's just that you guys know this. But this is not the linear process. So in traditional software, it's more like a linear. You just go through this process, and then you get the result at the end. Decide whether your evaluation is pass or fail. It's pretty straightforward. But in AIware, it might be not, because when you're doing execution, you may see like, oh, okay, this result is weird, and you need to go back to see, okay, my task design is good or not, or the data set design is good or not. And then after you fix those things, and then you go back to execution the task again. So you're gonna do this kind of back forth iterative the process, and then eventually get the evaluation result. So it's not as easy as you could imagine. So actually, Hassan says that if you could iterative this evaluation process quickly, means you get successful of deploy your AIware product into production. And as I mentioned before, like because you need regular updates for your new changes, new requirements, and you may get like user feedback, or you would have like new data on the production. So all of these things is that you need to do the evaluation as quickly as possible, so that you could always ship your qualified AIware to production. So I'm going to talk about like evaluation primitives. And this is the primitives I'm going to talk about. It's more about the common ones. I'm not able to cover everything in this session, so I just give you guys the common ones, but you could go more if you like. So the first one is about the task. So common evaluation task would including text generation task, which means you want to do summarization, like give a large topic or large documents, and you want to just give a simplified results, like summarize the paper, summarize the news, or maybe you want to summarize your knowledge so that you could do the reg stuff more efficiently. And another one is like question answering, so just give a question to a model and then gather the feedback from the model. Is kind of typical use case in terms of chatbot is so popular right now. So that's one. Another is like machine translation task, like translation from different, across different language, English, French, and then like English, Chinese. And also like dialogue generation task, which means it's gonna be a conversation, and then the conversation context that you wanted to evaluate. And also like name entity recognition task, which means this is more like the grammar stuff, or you want to give a spatial recommendation for a certain tokens, like if you have a certain location, if, for example, for advertisers, if you want to give a certain ads for a turn of like Changtou, like recommend which spot would be most popular in Changtou, and then you need this kind of evaluation, and also like language modeling task, which means you wanted to complete a sentence. And also like task classification, this is more like even machine learning could do that, but now like people will use foundational model to do that. And the next part is about code generation task. So I think this one everybody is quite familiar with. Like people already talked about in the past few days, which means you wanted to generate a certain code, or you wanted to complete a certain code by foundational model. And also you could generate a full program. Another one, this is more about like which in traditional software like called non-functional requirement, which means you wanted to know the safety or the toxicity or like legal aspect, but in AIware, this is quite important compared to in just traditional software. So like the example I gave, the BIOS example from the Google Gemini, and then there's another BIOSes like gender BIOSes or racial BIOSes or cultural BIOSes, and also legal issue, that's quite important, like the private data from the users, or like the specific information that you're gonna use in the models. Those kind of things you need to make sure it's gonna not leak to the public when you ship your AIware to production. And reliability, yeah, I also gave example Air Canada. So hallucination is the most important topic. You're gonna heard around a lot. And another one is more about consistency. So because the model was able to generate creative content, so that the result was not consistent across the time compared to traditional software. So that means you need to make sure it's always reliable in your context. So that's about tasks, but actually there are more tasks that you could imagine, and you could just Google it, a lot of stuff there I'm not able to cover. I'm talking about data set. So data set, I'm just give a simple comparison about across these three types of data set that you would use in evaluation. Gopi already covered how to generate those kind of data set stuff, so I'm not going to cover about that. So I'm just comparing the three kind of data set. First is human creation. Yeah, it's very good. You're gonna have a perfect data set for your evaluation because it's customized by human, it's also reviewed by human. But the problem is it's gonna be it's gonna be time consuming and labor intensive. And sometimes, because we're going to talk about the foundational model, so foundational model is gonna answer these kind of questions in natural language. So it's based on the human who create those data set. It may be biased or it may be not fair. That's for human creation. And for synthetic data, yeah, it's more flexible in terms of you could create a large amount of data and it's scalable, and also avoid those kind of sensitive data or private data in your testing data set. But I think Gopi already mentioned that if you're using synthetic data, which means it might lose the complexity or the diverse of the data you generated, because it depends on the algorithm or the technique you use to generate that synthetic data. And the third one is more is about existing data, which I'll talk about later. It's about benchmarks. So I think people already covered this topic a little bit, like many popular benchmarks, human evolves, or like MMLU you may heard in the past few days. Yeah, like the good part is also, yeah, these benchmarks are also a good standards, and because it gives a comprehensive evaluation of a certain amount of data, and it's cheap because you just download the benchmarks and you are able to perform, you are able to evaluate the performance of your AIware or foundational model. But the problem is also there, like it's specific to a certain data set. Like MMLU, you're just able to evaluate those kind of topics in that data set. You're not able to have additional topic that's specific to your context or your product. And also this benchmark has been created. Once it's created, it will be there for a long while, and it's gonna keep updating that, so it's easy to be out of date. So this is more about the data set that you are going to use for evaluation. Just make sure your evaluation is qualified, so you need to know what's the good part and bad part about the data set. So I'm talking about, next I'm going to talk about test strategies. So for test strategies, there are more than 40 types of test types in traditional software. And I'm not covering that, like you could talk about performance, you could talk about whatever others, but I'm going to talk about more like fundamental ones, like unit tests, regression tests, and back testings. So compared to traditional software, unit tests you should all familiar with is that you're gonna test a certain function or a certain library or certain class with respect to the predefined test case, and then the function, the class would be able to have a correct answer. It just exactly match, pass or fail. It's no optional. But in AIware, because the model is inside there, so it's gonna be dynamic output, and then it's gonna be context dependent, and also like depends on those kind of parameters you use when you ask the model to do the inference. Those kind of stuffs are more like dynamic, so that's the differences between AIware and traditional software. And then the regression test is similar to unit tests in traditional software. You're gonna have a full test case. You could do all the user scenario that fit to your business requirements, and then you are able to define that as pass or fail. While in AIware, yeah, like you're gonna have a bunch of prompts as your input to evaluate the performance of the AIware, but you're not able to verify the output or the response of the AIware based on those prompts. And the third one is back testing. This is more only focused in traditional software. This is only used in most of like financial aspects, because they wanted to evaluate when there is a new algorithms, and they want to make sure the algorithm works on the past data before they ship into production. While this back testing is quite popular now for AIware in general, because now we're gonna have an open-end response of AIware. So we want to make sure once everything changed, it's gonna be also working for the previous data set, but it still work for the current changes. So back testing is more quite new in terms of like AIware compared to traditional software. So that is something I want to talk about. And the next is about the differences in testing. So traditional software, deterministic. You just once pass or fail. There is no third option. You just have pass or fail. So it's kind of like static. You just know there's just 0 or 1. There's no true or false. Whatever ways you call that, there's no additional. And you were able to quantitatively evaluate your traditional software by your test cases or test suites. So I think you already heard like there are a lot of like test cases, like or maybe in CI/CD pipeline to evaluate traditional software. But when we're going to talk about like AIware, the first is probabilistic, because the foundational model, the default is gonna predict the next token of a sentence. It's not deterministic. There is a distribution of words for the given context, and then the model is gonna decide which one is most relevant to the current context. And so that is, for testing, is more about adaptive. It's not static. You make sure everything is gonna be adaptive to your context. And you're going to evaluate the quality of the AIware instead of the quantity of the AIware. Like I mentioned before, again, you're not able to generate all kinds of test cases and the test oracles for evaluating your AIware. So this is more about like the key differences in testing. So when you are evaluating your AIware, you just need to know this is like the fundamental concept when you start to talk about evaluation. And so, yeah.
Are there any AIware unit test frameworks?
Pardon?
Are there specific AIware unit test frameworks, or we can use the existing unit test frameworks for conventional software?
For unit tests in AIware, there's no difference if you are talking about the components. I mean, the components built by Huawei, the traditional component. You could use whatever test framework you have for those. But for the AIware, the most special one is about the model. The unit test, if you want to do a unit test on the model, there are a lot of benchmarks. You could test the capability of the model. But there, if in terms of talking about the framework for testing the model, I would just say there are a lot out there, but you need to figure out which one is more feasible to your use cases. Because most of them, as I know, it's more about just using the benchmarks to test the specific capability of the model. Yeah, so it's, you may not need to use a certain framework. You just write the code to prompt the model. Yeah.
Thank you.
Any questions so far? Other question? Okay. So after you do testing, you have some errors, and then you need to do error analysis or just saying debug. So this is just a simple process when you are going to do the error analysis. So the first one is analyze the failure case, is try to find the error patterns or the error modes, and then you try to compare whether this pattern is reasonable, maybe by A/B testing, or you could use the fine-grained data explanation. Try to look at your data why this data get error or why this data is correct, and then you try to fix the bug and then verify the changes you made, make sure it's working, and then go back to the testing again. So the process is quite simple, as what I just say. But I'm going to go through the use cases so that you get, if it's not that easy. So RAG, I'm going to talk about RAG again. I guess everybody should be familiar with RAG. Yeah, simple RAG is retrieval and a generation part. So the graph I'm showing here is from like Ragus, the framework I think Kahelia spoke before. So for the generation and retrieval, there are 4 dimensions. So when you're doing evaluation, you need to think about this kind of dimensions. And then when you think about the dimensions, you might want to derive all these kind of metrics. The upper table is more about the retrieval evaluation metrics, and the down table was about the generation evaluation metrics. I'm not going to read through all these metrics. You could read it online if you wanted. This is all the metrics you're gonna have for debug your RAG system. And then you got a lot of numbers you collect because of these metrics. But the question is that this is the RAG. I showed this picture before. So you're gonna have a lot of metrics. So are you able to identify where the bug is in these pictures, or you're not able to use those kind of metrics to identify these bugs, because there's so many metrics there, and then some metrics just cover maybe guardrail and then retrieval, or retrieval and this process. You just have the metrics for specific interaction between the components. You're not going to have an overview of the AIware. So this is kind of like example when you are doing evaluations. But this is more about just the interaction with component like retrieval and generation. So what about data? If there is a bug in data, how you gonna find it? This is an open question, so I'm not able to answer it right now. I'm just give you guys like the flavor of when you are talking about evaluation. You need to think about a lot of stuff that the topic we've been covered in the past few days. There may be a bug in prompt, there may be a bug in data, there may be a bug in your components or tool, or maybe there's a bug in the interaction, or your upstream tasks affect the downstream tasks. So that was about the testing strategy. And next one, I'm going to talk about the approaches and methods. Pardon? Yeah.
I expect that we can say that this is the probability, which not probability, which what certainty the result is accurate, or at least have those tokens probability. I was wondering, can we in those models are they evaluate to let us say that if it's less than, for example, we set it, if it's less than 0.6, then say I don't know instead of giving a wrong answer.
Yeah, you're talking about like guardrail stuff. So you wanted to protect your AIware, so you could set certain like threshold or rules for protection the response of the foundational model. But the case I was showing was about the RAG. So the RAG maybe in your use cases, just these use cases, you set the threshold of like, for example, 0.6, that is reasonable. But for another use cases, if you set a threshold of 0.6, it doesn't make sense. For example, like Huawei Canada case. I think 0.6 is quite low in terms of like the accuracy score. You might need to raise it to 0.9. But in terms of like finance aspect, like you just want to predict, for example, like a financial assistant, you just want to give the customer advice of like how the overall economic trend is going to like. So the accuracy maybe 0.7 is acceptable. So it depends on your use case scenario. You cannot just define one threshold for all use cases. Does that answer your question?
In the research papers, they show it as a metric for evaluating their work.
Evaluating, pardon?
Their work, to say that, for example, with this amount of cost of all those metrics, they get the 0.6, for example, as the accuracy, and it shows it with this amount of work and tokens, for example, in ChatGPT, but in our work, is work with this amount.
Yeah, if that paper say that, you could try that.
No,
but
I'm saying, is it the way they protect? I'm not saying, I'm not suggesting, I'm saying that, is it the way they do evaluate their work?
In my opinion, it's just certain use cases, because they have their data, their scenario, their use cases. So they would do, must did some experience on their data set and make sure that threshold is reasonable in their use cases. But if you switch to another use cases, it may not work. Yeah. Any other questions? Okay. Next one is talking about approaches and methods. So common approach include human evaluation. So this is quite straightforward, so I'm not going to say about detail, just ask some human annotators to annotate a given set of test cases. And there are 3 common evaluation methods, which is reference-based. Like usually in industry, you're gonna have a golden set that contains the predefined best reference results that you expected, so that a human annotator could score your AIware's result based on those reference data set. And another one is reference-free, so which means there is no predefined data set. You could score that based on whatever you wanted, I mean the knowledge of the human annotators. And the third one is pairwise comparison. In the reference-free method, which means there's just a random context. For example, you want to evaluate a summary of a paper. So you just have a summary and the original paper. You're not able to define like, oh, it's like, give you a score range from 0 to 10. You're gonna assign this A or assign this 5 or assign this 9. I'm doing that just by my gut feeling. I feel it's also good, I just give 8. Or maybe it's relatively okay, I give 6. But while in pairwise comparison, you got the result of 2 different summaries for the given paper, and you're able to read those kind of results, and you will say, like, for example, A is better or B is better. So it's kind of like an alternative way of like reference-free evaluation. And here's just the pros and cons, and I already mentioned that a little bit because I don't have much time, so I'm not go through it. So pros and cons, like have the reference base. The problem is like you just standardize, just only have the predefined benchmark, and reference-free is kind of like maybe biased and not consistent, and pairwise, you're gonna have a large amount of comparison in terms of you want a robust evaluation. And there's another one for casual, which is called casual evaluation or just vibe checks. Because human evaluation is quite costly, you need people to annotate that. So vibe checks is that you wanted to see how things performs from like any kind of platform, social media or whatever blogs like you could see. So the good part is low cost, and you might see some kind of like edge cases that people already discovers. But the problem is it's just subjective, and sometimes it's be gained. So it might be validated in certain scenario. You need to decide that by yourself. And next one is talking about automatic evaluation, which is more like more better than human evaluation in terms of like scalable, repeatable, and standardization. So 2 common methods is benchmarking and automatic metrics. So for the benchmarks, which means you have a standardized way to evaluate your AIware, and then you get the output. And in terms of you are evaluating a foundational model, now it's like there's a leaderboard layer, kind of have the competition of different kinds of model given a certain evaluation benchmark. And just list all the benchmarks as much as possible, but there are also more in the internet, so I'm not go through all of these. You may be familiar with part of them. And I'm only highlight one of them, which called human eval here, but I'm talking about automatic evaluation. So actually when you heard the terminology I said at the beginning, there are some terms are interchangeable and sometimes confused. This one is super confused when I first heard that. Human eval is actually a data set, and you're going to do that in kind of like automatic way. But human evaluation means you wanted to ask human annotator to do the evaluation manually, like label the data like one by one. So this is just something I just want to highlight a little bit here. And another one is that I already talked about the leaderboards or arenas. So here's an example of leaderboard. This is the Hugging Face one. So there's kind of like the field here about the model or like the scores of them, and then you could like add the additional information there. So in terms of the leaderboard, so there's 2 common ways, workflows for get the data up to the leaderboard. The first one is like you just have the evaluation by yourself, and then you could upload the evaluation result to the leaderboard, and then the leaderboard would have the extraction process and then integration process, and then the data will show up in the leaderboards. And next one is more about you have a new model has been developed, and then you're gonna submit your model, and then here's the information you could fill in, and then the model would do the inference for the given benchmarks, and then the leaderboard would extract the prediction result and then integrate that into their data, so that it will show up in the leaderboard. So this is a good spot where you wanted to see the performance of foundational models. And another one I talk about is automatic metrics, so which means there are a lot of metrics that is used to automatically evaluate a certain situation of your use cases, like text generation, Blue, Raj, Meteor. I think people already talked about that before, and also model performance, perplexity, which means you want to know how confused the model is, or burst score, glue, accuracy, and extra. So I think I'm not going to go through this matrix. You guys are smart, so just go online and see this kind of algorithm. I'm not go through, I just this here, and this is perplexity. I just highlight because it's quite important when you're doing the unit tests and you want to know how confused your model is. So you might need to just get familiar with the term perplexity, but you don't need to know like the detail because there's already libraries or function there, you just call it. And here's the comparison between the three evaluation approaches that I already talked to. So human illustration, benchmarking, and automatic metrics. Yeah, again, sorry the time. I don't have much time, so I'm just go through this. And the next one is foundational model evaluation, or I'm saying that AI as a judge. So actually, it's kind of a automatic, it's part of the automatic evaluation, but it's not automatic evaluation. I'll say why after. So basically, you're gonna leverage foundational model because it's able to evaluate the the dynamic output of the AIware. So it's more like kind of like replace the human annotators by giving a prompt. So here's an example, like you give a system prompt saying like you are a judge, and then you need to evaluate the quality of the response, and then you're gonna give a score of range from 1 to 10, and then give a format like this. It's just a prompt stuff that you guys are supposed to be familiar with, and then you give the question and give the answers. And yeah, like I say, it's similar to human annotation, so you could apply like human annotations evaluation methods, reference-based, reference-free, and pairwise comparison in the context of AI judge. And Jiahuei, I think Dai talked a little bit before, so this is a Microsoft proposed framework for AI judge, which means you use chain of thought to evaluate your result. So here is just you give the evaluation criteria like coherence from 1 to 5, and then you aggregate result to give a final answer and gather all the results here. So because you could use the prompt to generate whatever kind of metrics you wanted, so it's kind of good part because it's easy to develop any kind of metrics you wanted, like answer relevancy, correctness, or hallucination that I showed before for like the RAG cases. And it's easy for users to do this because you just write like natural language. And another way for AI as judge, you could do fine-tuning. I think we just talked about that this morning. So either like on the left part of the slide was about a small model, CAPI. It's just only 360 million parameters compared to like the current foundational model like 7B or like 70B. It could like outperform for like large models in terms of like language understanding task, and it's cheaper because small model would consume like less resources. You could check the paper if you want more detail. And Prometheus is another one quite popular because it could achieve like high alignment with human in a Pearson correlation of 0.90. And compared to GPT 3.5 or even GPT 4, only like 0.88 and 0.39 respectively. The idea of that is more about they use GPT-4 to generate the response of a certain use cases, and then use that as a data set to train the Prometheus model. So in this way, actually, it's quite expensive because you now have costs when you are using GPT-4, and then you have costs to fine-tune your specific model as a judge and then do the evaluation. And if there is some bugs inside there, you need to reprocess this again. So again, costly. And another issue is when you are using AI as judge, the foundational model are BIOS, like example I showed at the beginning, the Gemini. So there are two like common BIOSes that is important when you are using AI as judge. The first is precision BIOSes, as shown in here, like usually model prefer the first answer. So like the first answer, the second answer, which one is better? The first time the model say 1. And you just flip it the order, like the response 1 or response 1 comes the first, and the response 2 comes to the first, and the response 2 comes after, and then the model say response 2 is better. And another one is similar, like you just ask the model to score it, and then like you just flip the order, and then the result changes. So this kind of bias in terms of evaluation. And another one is verbose bias, so which means the model prefer more verbose context compared to a simple context, even though the simple context is correct. So this is also quite kind of like it's kind of like give you an invalid evaluation result in terms of you want to know the quality of your AIware, but it's going to give you a wrong answer of the evaluation. And there's a lot of biases there. I'm not going to go through. So this kind of the bias. The left table was about the bias, and the right table is about the metrics. You're going to identify those kind of bias. So evaluation is not easy in the AIware. So this is the common challenges for like you want to ensure high quality of judgments. So productivity, efficiency, and correctness. So productivity means how you're gonna evaluate your AIware or foundational model. So first is about your goals or requirements that I put in the previous slide in the evaluation process. The first step, you need to know the goal, and then you need to know evaluation criteria, and then in the middle, efficiency, which means you want to evaluate your AIware. You're gonna have additional model code. I mean foundational model code. So it's just remember we are doing evaluation. We are not building the AIware. So you're gonna have additional code, which means it's gonna be costly, and it's gonna be delay, increase the latency of your AIware because you need an additional model code. And correctness, I covered a lot before, like the biases problem or like the rationale of like the preference of the model family stuffs. So I'm just going to walk through use cases to let you guys get more familiar with the AI judge stuff. So commit message generation. So which means you want to know the message of a given commit. So this is an example, like this is a commit change, and this is the commit message. So your goal is you want to evaluate how good the message is. So you may firstly think about like the commit message should be clear, concise, but is that enough? Actually, it's no. And then you're gonna have certain iteration to have a more like reliable version, like this user is clear, discriminative, and blah blah. And then you have your data sets, which means those diff and the messages. And then you give a judge, and judge give you an answer. And then you're gonna do this across all the data set. And then you have the result you need to evaluate. And then you figure out, okay, the evaluation requirement is not clear, and then you just make a change, another one, and then you replace that. So you need to do this all again in terms of you want to get a good evaluation result. So yeah, this is more like the evaluation criteria that you may think of when you analyze your results. And then the next one is which model you should use for as a judge. So there are a lot of models, and the models have different capabilities. And then because the limitation or the biases I mentioned before, so you're gonna have different kind of like cognitive architectures to adjust the limitation of judges. So this is kind of like my current research work. So I use a search-driven constitution-based framework, try to transform the evaluation criteria into a genetic principles that could outline the constitution. And then I use search-based, search-driven algorithm to find the most optimal cognitive architectures for the judge system. This is more about the 4 stages. I'm not going to go through that. So the performance, the evaluation results of that framework is about, the first is I did my experience on the commit message generation CMG task. So I got like the majority of the principle or the evaluation criteria I used could be reused across the time or across languages. And another one is I use this kind of principle to give the foundational model to evaluate the performance of the commit message. It could increase the performance by up to 6.2. And the next one is eval optimization. So I'm talking about eval in dev mode and production. So in the development mode, actually everything is like offline. But when you're going to production, you're gonna face additional use cases or additional data or new real-time compliance stuff. So that is why you need to think of like evaluation in a wide aspects. So actually this kind of like stats data, like 90% of the Gen AI apps actually didn't go to the production because they're only able to cover like a small percentage of use cases when they are doing evaluation before production. And another is like latency I mentioned, cost, and also consistency. And because you're doing the evaluation, and then before go to production, there are also like the problem with the cost, like running benchmarks is costly every time. I mean, in the CI/CD pipeline, once something changes, if that doesn't affect to the models, but you're going to run the tests for the whole benchmarks as well. So you need to know how to minimize the cost or minimize the data set. And the next one is about like what kind of model you should use. I think Kirill already talked about like the model routing or those kind of stuff, but that is in the use case of you are developing your AIware. But now I'm talking about you're going to evaluate your AIware. So it's like an additional thing, so you may need to think about how many codes would be add on when you are going to doing evaluations. So this is small, you could choose small models before going to big models. And make sure you focus on data quality, not quantity. Like in this work, they mentioned they just use 10% of the original data could outperform the model trained by full data. And the last part was about evaluation of eval. So I mentioned evaluation would be also evolving over time because you're going to evaluate your AIware based on your specific business context. So you need to think about your evaluation is going to evaluate criteria is evolving, and how do you perform that evaluation based on this evolution. And another one is also like foundation model is also evolving. So you need to think about if the foundational model is the reason they make your evaluation result invalid. And there's also other components like prompt, tools, data, unique tactics also evolving. So you need to think about that. And this is my ending slide. So just recap what I got back to my first slide. So you guys, do you know how to evaluate your AIware? Thank you.
Thanks, Justina, for the excellent talk and a comprehensive overview. We have time for maybe one question. Danny. Okay.
So much, Justina, for a very nice, very informative presentation. So, with the evaluation metrics with Blue and Code Blue, and there's a lot of researchers that were showing that a lot of those evaluation metrics do not correlate with for software engineering tasks, do not correlate with how humans perceive quality of the code. And what do you recommend? What are some of the automated metrics that you have seen that work well and are better correlated with human evaluation?
For code generation task?
For code anything code related, yeah.
Yeah. For code generated tasks, usually the first thing you want to evaluate if the code is executable. That's the first mandatory thing. And there was a recently published paper on arXiv. They were talking about using a foundational model to predict the generated code is validated or not. So which means they're going to use another foundational model as a judge to judge the generative code. And then they also use another code-related metrics that we already use in static analysis, like the numbers of line or the complexity of the classes to as an indicator and combine to as a aggregate score to predict the reliability of the code that generated by model. But I personally didn't try that, but the thing is that if you wanted to add additional judge for judging your code, it's way much costly than you just execute that code. You just execute, then you use CPU, right? You use judge, you use GPU. So execute, you get the result by CPU computation. It's way cheaper compared to you use judge. So in the code use cases, usually people still use the just executable as the metrics to evaluate the performance of the code. Yeah, but in terms of like text, generated context, there's more a variety of ways that I show the automatic metrics. Yeah.
All right, thank you.
Let's thank Justina once again.
Thank you.